Okay, we ready? Hello? Up here? Hey. Okay, loops and iterators. Okay, we're going to look at how do we use loops and all the different types of loops in Ruby, of which there are a lot. So how do we use loops? Loops are used to repeat the same block of code some number of times or until some condition is reached. So here's an example. If we have a variable number with an initial value of 5, and we want to multiply it by 2 until the number is greater than 100, and then print the result. Yes, Jai?
Have you pasted the URL to the document?
I haven't. Thanks for asking, Jai. I'll do that now. I'll put it in lessons. Okay, so if we have a variable called number, and it's set with an initial value of 5, and what we want to do is to multiply it by 2 until the result is greater than 100, and we want to print the result. That's what we want to do. This is something that would require a loop. Okay? So here are the steps. We have a number initialized to some value. Yes, John?
It didn't go through.
It didn't go through. It's in lessons, not in everyone.
No, I'm in lessons.
You're in lessons. Oh, no. Okay. Sorry about that. That's what happens when you have this many Slack workspaces. Thank you, Jai. Okay, so we set number to some value. We say number equals 5 in this case. We're going to multiply number by 2. We're going to check if the number is greater than 100. If the number is greater than 100, we'll print it. And if not, we'll multiply it by 2 again. And we'll keep doing that until the number is greater than 100, and we print the result. Then we'll stop. Is that clear for everybody, what we want to do? So if I wanted to make a flow chart, it would look like this. We set number to an initial value. Number equals 5. Then we check, is number greater than 100? If it is, we print the number. And if it's not, we multiply it by 2. And then we check again. Is it greater than 100? If it is, we print it. And if not, we multiply it by 2. And then we check again. Right? So, where's the loop? Can you tell by looking at the flowchart where the loop is? Yeah, Jai?
The number goes back over, the multiply by number. The number, if it's greater than 100.
Mm-hmm.
And then, if no, goes down and then multiplies equals 2.
Yes.
Goes back up and then checks again. And repeats that process until it gets to 100. And then goes puts the number.
Exactly. So when you make a flow chart, you can see visually. For some people, this works really well. It just depends on how you see things. Some people don't need a flow chart to be able to see the loop. Some people, it's more intuitive to just see it in the problem statement itself. But if you make a flow chart and you practice making flow charts and make an accurate flow chart, then you can see really clearly where the loop happens. It's where an arrow points back to a previous step. The arrow points back to a previous step, that's where a loop is. So what is the exit condition?
Number greater than 100.
That's right. Number greater than 100. We can see that's how we get out of the loop. So this arrow goes back, and we go through this process again and again, and the only way out is here. And that happens when number is greater than 100. So that's our exit condition for the loop. What code would go inside of the loop? Could be depending on the type of loop that we develop. We could do it with an if statement, but what do we do inside the loop? So say the number is less than 100 still. What's the code? What do we do each time we go through the loop? What do we do to change? Yeah, so what goes inside the loop is the code that we repeat over and over again that generally is changing something that we're checking for an exit condition. Okay? So what goes inside the loop in this case is number equals number times 2. Does everybody recognize this syntax? So I have number times equals 2. That's a shorthand for number equals number times 2. So we can do that with plus equals, minus equals, divide equals, multiply equals. Number equals number times 2 is what that is a shorthand for. So what code would go before our loop? So before we even check if number is greater than or equal to greater than 100, what do we have to do first, Aiden? Outside of the while. Before we even get to the while, what do we need to do? Yes, we have to initialize the variable. Very important because that variable is used in our exit condition. So if we don't set it to something before we check it in our loop, we're going to have a problem. So it's really important that any initialization of our exit condition variable or variables happens before we enter the loop. Okay, so we have to set number equal to something before we even start this loop. And what code would go after the loop? When we're done, we've reached the point, we've reached the exit condition, what code goes outside of the loop, that's outside of that blue box, after the loop?
Puts number?
Yes. So what would happen if we did puts number inside of the loop? Yeah, we'd see it every time, exactly. And if what we want is to see the number after we get past 100, then that needs to go outside of the loop after the loop is done. Okay? So one of the most challenging things for people who are new to programming with loops is really understanding what code has to go before the loop starts, what code goes inside of the loop, and what code goes after the loop ends. People get that wrong really easily. Okay? And then it leads to the loop not behaving the way that you expect it to, and the program not behaving the way you expect it to. So drawing a flow chart like this can be a useful learning tool to get comfortable with, because you can visually see, right? You can visually see that we have to initialize number before the loop. You can visually see that we want to print the number outside of the loop and after the loop executes, and you can visually see exactly what code goes inside of that loop and what the exit condition is. Does that make sense? Of course, it depends on you knowing how to write the flowchart, how to draw the flowchart, okay? And that's probably step 1. But if you get to the point that you know how to draw the flowchart for the problem, then you can easily see what the code needs to look like. So let's look at some different loop types. The simplest type of loop in Ruby has this syntax: loop, do. And then your looping code goes inside of there, and you end the loop with the word end. In Ruby, you end all blocks with end. If it's a method definition, if it's a class, an if-else statement, a case statement, a loop, they all end with end. That's how Ruby knows that you're done defining this construct. So this type of loop does not have an explicitly defined, explicit meaning it's not in the declaration of the loop. It doesn't have an explicit exit condition. And by default, this loop will loop forever. It won't ever exit. Code inside of this loop must terminate the loop, either by using a break or by using a return. Okay? Otherwise, this loop will execute forever. So the keyword break is a keyword that can be used to exit a loop from the code inside the loop. So let's look at the example using this construct. We would set number equal to 5 before we even start our loop. We don't put an exit condition on this type of loop. So we just say loop do, and inside the loop we would have to use an if to check for the condition. If number greater than 100, and we would have to use the keyword break, or we could use return, but return is going to exit whatever we're in here. If we're in a method, it will return from the method. If we have this loop defined in our main program, it will exit the program. So you don't typically want to do return unless it's defined in a method. So we could use break here to break out of the loop. And then otherwise, if number isn't greater than 100, we'll multiply number by 2 and set number equal to that result. And outside of the loop, we print the number. Okay? Is that example clear? Okay, so that's one way we can make a loop. We can also use a while loop. So a while loop has the following syntax. We say while, and we explicitly put the exit condition in the while loop declaration. So while condition evaluates to true, we do the block of code. And then, like everything else, we end the while with an end. So a while loop will continue looping until the condition evaluates to false. Until it evaluates to false. So as long as it's true, as long as condition evaluates to true, it will keep doing what's inside the code. So in this example, we say number equals 5, and while number is less than or equal to 100, that's when we want to keep multiplying the number by 2. As long as it's less than or equal to 100, in other words, as long as it's not greater than 100, we want to keep multiplying the number by 2. Once this condition, when is this condition going to be false the first time? When will it be false? Number less than or equal to 100. When will that be false? As soon as the number is bigger than 100. The first time we check this and number is bigger than 100, this is going to be false and we exit the loop. Okay? And when we exit the loop, we print the number. Okay, so let's just try each of these real quick in IRB. So you can follow along if you want. Well, let me just answer this. Okay, so let's IRB. And we'll say number. Do you want to do it in IRB or in a file? Would it be clear if I do it in a file? Let's do it in a file. So I'm just going to create a file called loop.rb. And we're going to say number equals 5. Let's try the loop version first. What do I do? Somebody tell me. Loop do. Nope. Stop helping me. Loop do. Then what do we do? Do we want to do less than or equal to? We could.
Just less than 100.
No, we can say less than or equal to. So what I'm getting at is that this won't be our breaking condition. This is the opposite of our breaking condition. So if we did it this way, what would have to go inside of the if? Do you see what I'm saying?
Yeah.
So if we wanted this to be our exit condition, what would we say? What's our exit condition? Greater than 100. That's our exit condition. And if we reach our exit condition, what do we want to do? Break. Oh my gosh. I've got some kind of, it's trying to help me. And then we're going to end that if. Yes? So that's going to get us out of the loop when we reach our exit condition. What do we want to do inside the loop? Number times equal to. And did we need anything else inside of the loop? Nope, that's it. Then what?
Then put number.
Okay, shall we see if it works? Nice. 160. Okay, let's try it with a while. Okay, so how do we do it with a while? What is that? So this is how we write it. Less than or equal to. Do. What do we do? Times equals. Int. Now, what do I have to do before the loop? I forgot. What do I have to do before the loop? We have to initialize the variable. And after the loop? All right, let's try it. Nice, we got the same answer. That's a good sign. All right, any questions about those two ways of doing it? Okay, let's look at some other kinds of loops. Until. Now this is like unless. I don't like it. It's like a double negative case. My brain doesn't like it. So the syntax for until, but if you like it, it's okay. Won't judge you. No judgment here. Until condition. So until the condition is true, do the following. You put the looping code there. Yes, Aiden? Yes, it's exactly the same. If we put a negative conditional in our while statement, which you should never do, but if you did, yes, it would be the same. So until condition is true, do the following. So an until loop will continue looping until the condition evaluates to true, which is the opposite of a while, which will continue until the condition is false. Okay? I don't like it personally, but so this is what that looks like. Here, we set number equal to 5 again, and we say until number greater than 100, our exit condition. Number times equals 2. So until that evaluates to true, then we multiply number by 2 and set it equal to that product, and then we put number. So let's try that one. So first we have to set number equal to 5, yeah? And then what's the syntax? Mm-hmm. 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 Yep. Yep. Okay, let's see. We should get the same answer. Yay! We got the same answer. That means we did the loop right. So you can see that's 3 ways to do exactly the same thing. And the way that you use doesn't matter. You use what you're comfortable with, what makes the most sense to you, what's the easiest for you to understand. Okay? It doesn't matter which one of those you use. So let's talk about some other ways to loop. Iterators. So an iterator is just a loop, but it iterates through a data structure or over a range of values. So some examples that we can look at is printing something 3 times or doing something some set number of times. If you know I want to do this many times, you know exactly how many times, it's not like there's an exit condition, then you can use an iterator for that. Another is if you have an array or a list of things. So for example, if we have an array of animals and we want to print each animal in the array, then we want to iterate over that array and print the animals. And another example is we've got a range. So we have like the numbers from 1 to 10. And we want to multiply each number by 2 and print what that product is. So let's look at these examples. So the first one, let's use times. Times is a method on a number type. So we have a number type. It can just be a number, any number, or it can be a variable that holds a number. and we say dot times. And what that does is it will loop that many times. So we say number dot times do, and then we put the code and end, and it will execute that code as many times as the number specifies. So a times loop will loop exactly number times. It's useful when you want to perform some task a specific number of times that you know. So to print hello 3 times, we could say 3 dot times do puts hello. So let's try that one. Okay, so if we said 3 dot times do puts hello, and it prints hello 3 times. Now we can, example 2 we'll look at, and that's printing each element in an array. One way we can do that is with a for loop. So we can use a for in loop. And the syntax is for item in list do, and we have the code, and an end. So a for loop will execute for every item in list. So let's look at the example. The example is we have an array of animals and we want to print each animal. So what we would do is we would say for animal in animals puts animal. Now the thing to know is that animal, this one, item, is just a variable name. We can give it any name we want. Okay? But we give it a name that makes sense. We give it a name that makes it really clear what we're doing here. Okay? But we don't have to call it animal. There's no rule here that says it has to be named anything like what it represents or anything like what the list or collection is named. I just chose to do that to make the code clear. All right? Whatever we name it here is what we have to reference inside the loop. So what we name it here is like a variable declaration, and we can access that variable inside of the loop. We can't access it from anywhere else. When we're done with this for loop after the end, we don't have access to animal anymore. We can't say puts animal outside of the loop. It'll say, I don't know what animal is. So let me show you what happens when we do that. I'm just going to start another file, so we back up at the top of the screen. Where's her name? Nope. Okay, let me do it a different way. Touch. Okay, so let's say I have animals equals dog, cat, and I say for animal in animals do. Puts animal end. Okay, let's try that first. Okay, and it prints the animals. Now if I try to say put animal here, oops, you have to spell the word right. Oh, it actually did keep it. I just lied, it kept the last one. So that's dangerous. It shouldn't still be valid outside of that loop because you shouldn't depend on that. So in another language, like if we did that in JavaScript, that would not work. So it looks like it keeps animal around and it will just hold the last thing that it was set to. So there you go. You should not depend on that. Okay? If you do, people are going to be confused when they look at your code and how it works. So even if it works, doesn't mean that it's a good practice, because in another language that wouldn't work. Yes, Jai? Say that louder.
What does this loop that I'm looking at do right now? It's not the for loop, but the actual loop itself.
So the for loop is the loop.
I don't know, but what's the loop?
So animals is just an array, and this for loop is going to loop over that array, the items of that array, right? So for each element in animals, it will get stored in that variable animal, and I'm just printing it. I'm printing the item. So we could, for example, I could say puts animal is animal. And it prints animal is dog, animal is cat. So this kind of for loop is useful when you have a list, when you have an array, you have a collection, okay? To print the elements, or to do whatever you want to with the elements. You can do anything with them, right? Now we can also use each. Now with a collection, I prefer to use each, but a for loop is fine too. Okay, and if you've been programming in other languages, you might be more comfortable with a for loop. But each is a method on array and on hash on collections or list types, list data structure types, and it does the same thing as a for in, but you call it directly on the list variable or the list itself. So the syntax is you have a list like animals dot each do, and then you put your variable name in pipes after do, and then you execute the code and put in. So it's much like a for. The syntax is just different. So it's like this: animals each do animal puts animal is animal end. And it does exactly the same thing. Now, if you want to get super fancy, it's not really super fancy, but an even more shorthand way to do it is to say and that works too. Okay, so this is called each with block notation. So you can see it's a bit more elegant because we don't have to have the do or the end, but it does the same thing. Okay, so some people really like this block notation, and it's useful when you have a small bit of code that goes inside of your loop when it's like a one-liner. Just like with the ternary, it's just sort of a nicer way to write it. But if that confuses you, don't use it. Okay? You don't have to use that notation. You can use the expanded, the regular each notation. You can use a for loop. Any one of those is perfectly acceptable. I would avoid using block notation when you have multiple lines in your loop. You can, but I think that just looks confusing to me, and it starts to look like you're trying too hard or something. I don't know. You're trying to impress people. But so I think my general rule, the way I like to do things, which is not to say it's the way you should like to do things, you should do things however you want, My way of doing things is when I have a single line in my loop, I like to use block notation. And if I have more than one line, I like to use the others. But don't feel like you have to use block notation, okay? And if you're not comfortable with it now, use for loops or each, regular each loops now. And then maybe later you'll get more comfortable and you'll want to use block notation. But I just wanted to show it to you because that way works too. And I didn't put that one in the slides because I just didn't want it to be confusing. Okay, so example 3 for the numbers 1 through 10, multiply the number by 2 and print the results. So we can use a range with a for in loop as well. We don't have to use a list or a collection. We can use a range. Okay, so we can say for I in 1 to 10 do. Puts I times 2. Okay, so let's try that. Now I said I, and that's a convention to use I when it's representing an integer in a loop or an index in a loop, a number in a loop. It's just a convention. You'll see for I all over the place. So that's why I use that. For I in 1 to 10 do puts I times 2. End. Okay? Now, just a little bit of something about the range. When you use 2 dots, it will include the last number in the range. So you see in my output, it went all the way up to 10, because I got 10 times 2 is 20. As counterintuitive as it is, when you use 3 dots, it doesn't include the last number. It'll only go to 9. So when I use 3 dots here, I'm saying it's not inclusive. It's excluding the last number. Okay? So if I do it like that, then we only go up to 9 inside of our loop. We only get up to 18, 9 times 2. That's confusing to people because in other languages it's the opposite, of course. Now why they did that in Ruby, why they made it the opposite of what it generally is in other languages, I don't know. But they did. Alright, so that's what I have on loops. Now, loops can get really complicated. Loops are the source of a lot of confusion when it comes to programming. And because loops can be confusing, I think it's a good idea to practice either hand simulating your loops when you run into a problem. And I'll demonstrate that when we, maybe with the next morning challenge possibly. I'll demonstrate how you hand simulate a solution or a piece of code. Or using an online simulator. There's a really nice one at pythontutor.com. You can use it for different languages. Ruby's one of those. You basically paste in a block of code and you can step through it. And it shows you what's stored in each variable and where the execution pointer is, and it's really nice. So I'll demonstrate that too as we have something interesting to look at. So have a play with different loop types, okay? You're going to write loops in probably every substantial piece of code that you write. Almost every morning challenge from here on out probably will have a loop in it. You just can't avoid loops. You know, we rarely do something without having to repeat some step or repeat checking something until some condition is met when we write programs. Loops are a super common construct in programming. So, so have a bit of an exploration with these different types of loops and try them out for different circumstances and see what makes the most sense for you and what's easiest for you to understand. I've looked at some of your work, so some of it was shared and some of it I've just looked on your computers. I just want to remind everybody to comment your code. So get into the habit, because it's so easy to not be in the habit. I've certainly been guilty of that so many times. You know, especially when you're like really into solving the problem, not commenting your code. So I'm just going to say it and I'll keep saying it. Comment your code. In fact, one of my favorite ways to develop code or to tell other people to develop code is to write out your pseudocode in comments. So do this, do this, do this, do this, and write it in comments, and then just fill it in with code. And then your comments are there. And you've thought through the way that you want to structure your program and your solution beforehand, and it's all documented there. And then when you have to deviate from that, and you will, so you'll think, okay, I'm going to do this and do this and do this, and when you actually write the code, it doesn't work out exactly the way you thought it would, and then you have to change it, then change your comments. But it does really help you to understand the problem-solving process when you do that, and have a better understanding of what you've done there. And commenting is important because even if nobody else looks at your code, even if you're only writing it for yourself, look at it a week from now and see if you remember what the hell you were doing when you wrote that code. You won't. You'll look back and you'll be like, why did I do this? This doesn't make any sense. But if you have comments and you're like, oh, okay, that's what I was trying to do. I didn't do it right, but that's what I was trying to do. Yeah, Jay.
Is making comments just / writing it out?
In Ruby, it's hashes. Yes. It's different in every language. So in Ruby, it's hashes. In JavaScript, it's //. Yeah. In shell scripting, it's hash. Yeah, and then there's multi-line comments. In JavaScript, is /*. It ends with star. /. Yeah, yeah. So you just have to look up the syntax for whatever language you're writing in. Okay, any questions about loops, what we just covered there? Okay, so if we look in Canvas. Yes, what's your question, Aiden?
How do you, how does it select the speed of it? I know loop that loops from 500 trillion down to 1.
Yeah?
And it hasn't even gone, it's only gone down by like a couple hundred million.
So how quickly it executes depends on a lot of things.
So is that like, will it just by default execute as fast as it can?
Yeah.
Code?
Yeah, so on a computer, there are a lot of processes running. There are ones you know about and a bunch that you don't know about. And they have priorities. They have relative priorities. So depending on the operating system, the other things that are running, the architecture of your CPU, so whether it's a, like Intel architecture or Power architecture, this...
And the RAM or the RAM?
Both.
So the RAM feeds the information to the CPU. Think of the RAM as like a so the less RAM you have, the more RAM you have, the bigger it is. But
Yeah.
at a certain point the RAM is big enough that the information runs through, so the sweet spot for RAM, the video is like your game is 16%, so it's going to be like 6. Yeah. 16 so it feeds the CPU. So all the information is like that's going through it. Right. So the bigger the tunnel, the faster it can be.
Yeah.
So if we only got 8 gigs in our laptop, that's coming through to my 12 that's getting so we can
So if you execute loops with input values that are too big, you can get yourself into a situation, a Stack Overflow situation, or you run out of stack space. That can happen. So you have to be aware of things like that when you're programming, if you're working with really large inputs. Okay, so if we look in Canvas, there is a challenge in Canvas, so remember that you should do your challenges in the directory that we set up this morning for your Canvas challenges repo. All right, so there's a challenge here on arrays, and then there's a beast mode challenge as well. So That's the challenges that are associated with arrays. So what I'm going to suggest that we do is work on these challenges, and at 3 o'clock I'm going to ask somebody to share where they've gotten, okay? So that we can look at it together. So work on this challenge until then. And if you've already done this challenge, then you can work in the workbook. You can try to refactor your code, make it nicer. There's always refactoring that can be done. You can refactor the banking app. If you've worked on the banking app, you can add some features to the banking app. You can do that sort of thing, okay? If you aren't sure what to work on, if you've done all of those things and you feel like you need something else, then let me know.